Hello everyone, welcome to another update, another devlog. I wasn't going to do this because most of the work I'm doing at the moment is in the deep down in the Z80 code of the Spectrum side, which doesn't really lend itself too well to video devlogs. And I had something else planned, which I'll go into a little bit towards the end of this video. But it turns out that while preparing for that something else, I ended up making quite some significant changes to Kwyll. So I thought I'd do this very quick. It's a fairly short one, I would imagine. Update of new features and changes, relevant changes to Kwyll over the last couple of weeks, and then feed into what I'm going to be doing in terms of these videos for maybe the next few. So without further ado, I'll jump straight into Kwyll, and we can go through some of the features that have been added. Most of these have been added in service of the work that I'm doing for the next videos. I've been actually using Kwyll more than I normally would, and in doing so discovered some issues and some weaknesses, and where possible I've immediately addressed those. Where there are issues, fix the bugs. Where there are weaknesses, find ways of making it more powerful, more capable. So I'll go through them I've got a list here, so I'll go through them in no particular order. So the first thing is there's always been a very limited early stage facility in Kwyll to be able to import data from other Kwyll projects. So it's not importing from other tools at the moment. That's something further down the line. But for now, if you've got a project with some sprites, sounds, etc., the idea was that you would be able to bring in those from other projects, so you don't have to start from scratch every time. It was very rudimentary. It was focused only on bringing in tiles and sprites to begin with, and more importantly, it only had the ability to bring in an entire tile sheet or an entire sprite sheet. So bring in the entire sprite sheet and add it to your list of sprite sheets. So if you go here, it would add a new sprite sheet here with all the imported sprites. And for the tiles, it would add them to the list of tiles, so just tag them on the end of what tiles you already had in your project. But I've changed that now, so if I bring up the import dialog, you can see how it's changed. I'll pick an example with some content in it. So we've got this. These are the things over here that you can import. We've got the tile set, and you've got the sprite sheets that are in the project that you're importing from. Normally what you'd do is you'd click on here and it would import that whole sprite sheet, but now what you can do instead is pick individual ones. So if you only wanted, for example, the Manic Miner character, you could just select those and it would just import those. Similarly for the tiles, if you only wanted the brick tiles, select the brick tiles. So that makes it a little bit more friendly and easier to pull in just bits and pieces, and it may even make it possible for you to have maybe some projects that you consider to be library projects. So you have lots of tiles, lots of sprites drawn in there, and you can just pull in bits and pieces from them when you start a new project. And the other thing that I've added to it that I'll need to select a different sample for is you can now bring in sound effects. So this is leading into what I'm going to be working on. I wanted to be able to bring in sound effects without having to manually transcribe the data for each one. So I could get the same thing. You've got these are list controls, so you've got control and shift, so you can shift select the whole lot, or control select individual ones. Command select on Mac, of course, and then import those, and then when you go to the sound editor you get just those new sounds that you've copied. So it just makes it a little bit easier, as I say, to work with existing content, and gets you up and running on a new project a little bit faster, hopefully. The next thing is to do with movement of objects. So if I load up let me load up the test actually. So background collision test. So basically, if we go to an object here, I've got a ball and it's got some logic on it. Now here you'll see we've got this, it's doing some basic movement. It's just moving in a particular direction as defined by these two variables here, x and y. And then this would normally be, if I just show you what the previous move object node is. So it's doing a very similar thing, takes a reference x and y, but this one has an output down here for if you've hit another object or intersected with another object and what that object is. This new one instead outputs information about whether you've collided with background tiles, which you could never do before. It was always the objects would always collide with background tiles and stop your progress if the tile or the collision map was set up to prevent movement in that direction, but there's no way of knowing within the logic that that had happened. So now this one will tell you that you collided with the background and you were unable to get to where you wanted to go, and in this output port here it will tell you which direction you've collided with a tile in, and it's a bit field. So for those not familiar with programming terminology, what that means is it's basically a binary value with 4 bits of relevance, one for each direction: north, east, south and west. So north I think is bit 1, south is bit 2, and then east and west are bits 3 and 4. And the reason for doing it as a bit field rather than just north, east, south or west is that you can combine them. So you can have for example, if north is bit 1 and you've collided north, then it will show 1, the value, the numerical value 1, because bit 0 in a binary is 1. And then you've also collided in the east, so you've gone up diagonally, you've hit 2 tiles. Then you could set the east bit, which would be bit 3, so you'd get a value of 5 returned, for example, because bit 3 is 4 in binary. So it allows you to combine and you can compare things. The reason for it being the bits being 0 is north, 1 is south, actually 1 is north, 2 is south, 3 is east and 4 is west, is that combining those two close together, the two verticals and the two horizontals close together, means I can do things like this. So what I'm getting here is I'm getting the output direction and I'm ANDing it. So this is a bitwise AND for people who understand. So basically it ANDs, it compares the bits of the numerical value, and the result is set if the bit is set in is 1 in either of the two inputs. I won't go into too much detail of that, but it's important to understand. So with 3, if I put 3 in and the direction, 3 is the first is bits 1 and bits 2 set, so the result is 3. So this will basically test if you've collided in the vertical direction at all, in either north or south, and it'll allow you to just very quickly test without having to do 2 tests. You can just AND them, and if either north or south is set, the result will be non-zero. So it's checking to see if it's non-zero, and if it is non-zero, that means you've collided in the y direction, and therefore sets the y movement direction to the opposite. So it's inverting it by multiplying it by -1. And similarly down here, if that is not set, it'll AND with 12, which is bits 3 and 4, and that'll detect any collision with the background in the horizontal axis. And if it detects one, it will flip the x direction of movement. So what that means is when you see it in play is it can detect whether you bounced off, which wall you bounced off which side, and change direction accordingly. So you can do cool things like that. It'll be very useful. I mean, that's just a very simple demonstration, but it will be very useful for things like detecting whether you're on the floor. So in a platformer, it will make the platformer controller much simpler than it currently is in the samples I've done up until now, because before you had to check whether you were able to move enough in the downward direction to complete the move that you wanted, and if you didn't, it was presumed you'd landed. This will make it much simpler to work out whether you've hit the floor and respond accordingly. So that's quite useful. Another thing I don't think this one, no, I'll have to load another sample. But if I quickly go to the ball in the room, now the ball object, if you remember, has two variables, xdir and ydir, and if you go into the room, this is an instance, this is the use of the ball within the room, it's this one here. And if you open this editor up for the properties, you can see it lists those variables. Now these are per instance, so you're not changing them on the object itself, you're changing them on the instance of the object. And each instance can have different variables. So if I dragged in another ball and open that one, I can set that to whatever I like, and that instance will retain those values, and this one's values are unchanged. So that's always been there, and that allows you to control the behavior of instances of objects in certain ways. You can, when you run the logic on an object, it's the logic itself is on the object definition, but it's referencing these variables from the particular instance of the object, the use of the object, if you like. So there's a similar concept in rooms and maps. So the rooms are definitions. You define a room, it doesn't do anything until you put it on the map, in the same way as objects don't do anything until you put them in a room or on the map. So here's our map, and we've got one room here, and we pulled our room in. Now rooms also has logic and can have variables. So if we put a variable on here and then we go to our map and we open this, you can see now we can edit variables default values for room instances as well, which wasn't possible before. It was much simpler, this dialog. So this is, I'll explain a little bit, well maybe I won't explain, but you'll see if you watch the videos coming up in the next few weeks why this was important. But it basically means you have the same capability to use multiple rooms, multiple instances of the same room on your map, set the variables differently and have the logic change what the room does, or that the room does in that particular location. So the terminology is these are locations and these are rooms. And a location is an instance of a room, much like an instance in here, room object is an instance of an object definition. So I'll probably be refining that terminology over time to try and make it simpler and less confusing, but hopefully that explains a little bit about that one. Okay, so moving on, the next one is related. So I'll load another file up that I've got, if I can find it. Yeah. So in logic, anyone who knows or has been following this knows you have a bunch of what we call triggers, and these are entry points into the logic. So always will run every frame, and you've got, if you look at all the triggers, you've got initialize and so on, and animation. I've added some new triggers, in particular for this feature, room entered and room exited. So if you've got a map with locations like this, as you enter a new location, the moment you enter that location, it will trigger any flows on the object, on the room definition for room entered, which allows you to do something specific or do something as you go into a room. And there's a partner one which is room exited, so as you exit, so if you go from room 1 to room 2, room 1 will first get room exited, which allows it to store any state or update anything, update scores and so on, and then immediately you move into room 2, room entered will be called on room 2. So so that's how that works. And if I've got this test just put together very quickly. So if I look at room 1, I've got an object on here, the bubble, and I've got 4 markers that I've put in. And if I look at the logic here on the room entered, it basically moves the bubble to one of the 4 markers randomly, and it'll do that every time you come into this room. So I've also got some code on here which just checks for the fire button and moves you to the other room, and similarly on here, just in this one's much simpler, it just checks for the fire button, moves you back to room 1. So if we play this, it starts off, it moves the bubble into one of the positions, one of the markers randomly, and if I hit fire it goes to 2 and then back. Of course it's going to go back to the same one, but it does do randomly, trust me. So that just gives you some control. And again, I'll go into a lot more detail about this in the upcoming videos about why this is an important feature for what I'm about to do. But it does give you a lot of power to make the most of reusing rooms in the map. So you can get away with a fewer number of room definitions. You don't have to have a room definition per location on the map. You can have fewer numbers of room definitions and have them adapt to different uses within the map, which gives you a great deal of power to optimize memory use. That's that one. Related again, if I go to the room editor, and this is just more of a fix, but a sort of an improvement as well at the same time. Down here, you'll have seen we've got some coordinate displays that show where your mouse position is on here, which are very useful when you're placing objects and painting and understanding the layout of the screen. And there are three of them. The first one is the pixel position in terms of the game window, so where you are on the game window. The cyan one is the cell, so the tile position, so 8x8 tiles, so you can see easily where you are on there. And the last one is for objects. So before, when you dragged a new object in, green would show where you were dragging it to, and that would be the purpose of it, nothing more. Now for both markers and objects, if you've got one selected, it shows you permanently the position of that object, which again is very useful when you're moving objects around, or maybe doing various logic things that involve requiring you to understand where an object or a marker is on the screen. So just a little convenience, but something that I'm sure will be very useful. Okay, on to the next one on the list. The list is longer than I thought it was, but we're getting through them. So the next one is another big one. So I'm trying to think if I've got a test for this. I think I have. There it is. Room message test. So this is a feature again about the triggers. So if we go to the room logic, I can show you. Actually, probably the best thing to do is if I show you the previous version of this same test content. So let me show you it running. So it's a very simple test. It's got some brushes and things in there. That's the main reason for the test. But it checks for collision with that key and pastes a brush over here. And the way it does it in that test before this new feature was the room logic is always, every single frame, checking to see if the global variable got key is set to 1, and if we haven't already pasted the brush of flowers or plants. And if those two are both correct or valid, then it pastes the brush and sets done, so it doesn't do it again. But basically this is every single frame is checking constantly, have we done it yet, have we done it yet, have we done it yet. And if we look at the object, the player, it's basically doing its moving around, and then if you collide with the key, it sets that global variable and then moves the key off screen out the way. So that sets the global variable, and that will then on the next update in the room logic will detect that the global variable has been set to 1 and do the placement. So that's obviously not very efficient. This just running over and over and over and over again, waiting for the key to be set. So if I go back to the new test and we look, so this is the room logic again, and you can see it's much simpler, and we've got this new trigger which is on message. So the concept here is you can send messages between logic flows on different things, objects and rooms. Currently the only thing that has the ability to listen to a message, or the only thing that we can send messages to, should I say, are rooms, but this will be extended to include objects, screens and global logic shortly. But for now this just shows you how it works. So basically this on message trigger, it has an ID, and the ID on the message, this is the ID of the message basically, and on the sender the message ID must match. So if it's sending message ID 1, it will run this flow, and you can have other so I can have another on message here, and this could be ID 2, and someone else could be sending ID message 2. So you can have multiples, and this now just needs to check for whether we've already done it, and if not, paste the brush and set done. And the reason we don't need to check for the global key is because this message will only be sent to the room when we collect the key. So if we look at the player logic now, same thing. The only thing that's changed is instead of setting a global variable which has to be monitored, it just sends a message to the current room. You can send to another room, but at the moment this one, because it has no reference, it will send directly to the room that we're currently in, the location we're currently in, shall I say, and it's message ID 1, and that's important that matches. You can send in up to 2 other parameters to the message, and these are for use however you see fit. They're just useful for defining things about the message. So for example, if I had different keys, different colored keys for example, I could put in a value in here that indicates which type of key was collected. But this just will send a message to the room, which will immediately be picked up by this flow and do the pasting of the brush. So if we look at this one, it won't look any different, but it is being much more efficient because the flow on the room, this flow on the room, isn't running constantly. It'll only run, this flow will only run when the message is sent, and only the right type of message. So it makes runtime much more efficient, and potentially the code size smaller as well. So that's a powerful, another powerful tool, and again I put that to great effect in the upcoming videos. This was designed and implemented specifically to support these upcoming videos that I keep mentioning. So moving on from that one, a couple of smaller changes, but sort of quality of life changes. I've noticed that I'm guilty quite often of using terminology that makes sense to me but maybe doesn't make sense to everybody, and as Kwyll is designed specifically to target people, or target's the wrong word, but to be used by people who maybe don't have the technical or programming experience that I do and others who are creating games on the spectrum do. This is designed specifically to make it possible for those people to create games. I want to try and consciously avoid using unnecessary jargon and unnecessary technical terminology. So I had some nodes. I've looked into this in particular on the nodes. I had some nodes that were very confusing names once I started looking at it and analysing it. This one in particular, this one used to be called integer compare. So now it's just if. It makes a lot more sense. So that one's changed. There was an integer constant, which is now, if I can find it, number. So if we just create a number, it's just a number because that's what it is. Integer constant didn't make any sense. I've also changed on the if and the other compare node. Before I had the symbols, the programming symbols, double equals, less than, greater than or equals. So I've just changed those to much more meaningful names now, so you can see exactly what you're working with. Just again, small changes, but hopefully to simplify some of the concepts and make them a little bit more accessible. And in relation to that, and another sort of topic that was raised on the Discord in the past week or so, is the concept of different coordinate systems. Now I'm aware that for me coordinate systems are second nature because I've been working with them for many years, but to other people I realised that the idea of having different coordinate systems can be very confusing. So I'm going to be updating the documentation to hopefully explain a little bit more. There are only 2 at the moment in Kwyll: map coordinates and room coordinates. But to support that, I've put these axes in, which show where the origin, the 0 point of that coordinate system. So in a room, the 0 point of the coordinate system is the top of the room, and any objects and things you place in here will be relative to that position, so offset from that position. And in the map, you have, this is the 0 position of the map, and the room, for example, is at 128. So if I move that up to there, it's at 0, 0. So these are the two coordinate systems. Any objects you have in here are going to be relative to the room in here, I mean. Any objects you have in the map are going to, so this one's a map object, it's going to be relative to the map origin, not the room origin, because it's in the map. And this one will be relative to the room origin. So these axes are just in there to help a little bit understand the difference between those two. But as I say, I'll be updating the documentation to explain in detail and hopefully make that a little bit clearer. And then finally, a new instrument type. So if I load up a sample that I've got, so in screens, for anyone who remembers, you have the concept of instruments. So these are instruments. If I turn off the tiles layer, you can see, so these are instruments. You can move them around, and there's logic nodes that allow you to make changes to the values in here, and these are the instruments. And up until now you've had either text, which allows you to display one of the text messages in the instrument. So score label, for example, is a text, and we can change what text is shown, or numeric. So score itself is just an integer value and it displays whatever that value is, and you can set that value from the logic. This one here is the new type, and it basically allows you to display a tile from the tile map in, so we can change it to grass, for example, and maybe change the color to green. And then when you preview and go there, you have a tile. So this allows you to use your custom designed graphics in instruments within the screens, as well as numbers and text. So it gives you a little bit more power. I am planning to add more instrument types, but for now that was the one I needed for my specific requirements at the moment, and hopefully can be quite useful and quite flexible. It is only a single tile at the moment, but that may change. So that's basically it for the new features. As I say, quite a list, some small, some much larger, and hopefully quite useful. I'll be doing a new release probably tomorrow now. But on to the thing I've been hinting at all the way through about the upcoming videos. So I've mentioned already that most of my work is focused on Z80 optimization at the moment, apart from when I do this sort of stuff. And that's not really great, I don't think, for devlog videos. No one wants to see me faffing around in Z80 code, assembly code, unless you do. If you do, put a message in the comments below, and maybe I'll do those as a separate thread, or a separate playlist or something. But my impression is from viewer ratings is that most people prefer to see the visual devlogs that show features in the editor itself, rather than deep coding stuff. So in order to not go too long without video updates, I've decided to take a slightly different tack for the coming maybe 3 or 4 videos. What I'm going to do is take a game idea, relatively simple one, and do a series of tutorials going from 0 to a fully playable game on the Spectrum using Kwyll. It won't be a blockbuster game, it'll be just a basic game, but it'll show you a lot of tips and tricks and techniques that I have as I've been developing Kwyll, that I've come up with for making the most of Kwyll in different ways. So it will try and push Kwyll in directions that the normal flow wouldn't take you. So for example, if you were doing a room-based game, the natural instinct is to create a room object, a room definition for each room, and then place each one of those on the map in where you want them. I'm going to demonstrate some techniques that can can do things slightly differently to that in a room-based game, and give you a little bit more flexibility to both fit more game into the available space and make things a little bit more interesting. So the game is going to be loosely based on the style of Attic Attack, in that it's an overhead room-based game where you collect things and avoid enemies, try to complete the puzzle. And I'll start maybe in a few days' time with an initial video that just shows me, goes through the basics of building out the project, putting the basics into place, describing a little bit about how I've designed the game, how I've designed the way that the game works within Kwyll. And then over subsequent 2 or 3 episodes, depending on how long I decide to take it, we'll be adding features, and at the end of it, the game I'll make available for anyone who wants to see it, and the project for anyone on the Patreon who has access to Kwyll and wants to see how it comes together. And it's using a lot of these new features, so these features have come along very specifically to support this tutorial project. So I hope you'll come back and have a look. Subscribe now so you don't miss out when I put the video up, and I'll see you all soon.